All right, welcome to this explainer. Today, we're diving into something that is honestly a massive paradigm shift in tech. We're officially leaving the era of reactive chatbots and stepping into the age of proactive, autonomous, multi-agent systems. Now, if you've been following AI at all, you already know this space is moving at absolute breakneck speed. But what we're unpacking today isn't just, a minor upgrade to how a computer talks to you. It's a fundamental, ground-up change in what AI can actually accomplish entirely on its own. So let's jump right in and see what happens when AI stops just waiting around and starts doing.
So what's the core difference between your standard large language models, the LLMs we're all used to, and true AI agents? Well, it really comes down to transaction versus action. Up until now, our relationship with AI has been super transactional. You sit at your keyboard, you type a prompt, and the model just waits. It waits for your instruction, spits out an answer, and then goes right back to waiting. Kind of like a passive encyclopedia. But imagine a system that doesn't need your green light for every single step. A system that shifts from being that passive encyclopedia to an active participant in your actual workflow.
And that brings us to what an AI agent actually is. Essentially, an AI agent puts the language model right at the center of the action and lets it decide the actual control flow. Instead of following a really rigid, predefined sequence of code like traditional software does, this agentic system evaluates the situation right in front of it. It decides entirely on its own when it needs to generate a search query, when to retrieve a file, or when it should just respond directly to you. It dictates its own steps to achieve your goal. And the result, a dramatic reduction in the need for constant human intervention.
To put this into perspective, think about the tools you might already be using every day. Basic LLMs? They're great talkers, for sure, but they don't do the walking. They can't plan or execute multi-step actions. Then you have copilots. These are really helpful sidekicks for coding or writing, but they still need you to keep your hands on the steering wheel to make those final decisions. And robotic process automation, or RPA, honestly, that's basically a robotic arm that only clicks exactly where it's programmed to click, using strict if-then rules. AI agents are a completely different beast. They combine the reliable autonomy of automation with the dynamic, complex reasoning of a modern language model. It's a real game changer. Okay, so what actually makes up the biology of an agent? Well, just like living organisms have different interconnected systems to function, a true generative AI agent relies on 4 distinct anatomical parts to operate on its own. These core components are reflection, tools, memory, and planning. Now, to be fair, not every single agent out there needs all 4 of these to function perfectly for its specific task, but when you combine them all, that represents the absolute gold standard of autonomous capability. Let's break these down a bit, starting with the brain.
Starting with reflection. This is an incredible metacognitive ability that lets the agent act as its own harshest critic. Just imagine an AI writing a piece of code, running it, seeing that it triggered an error, and then actually analyzing why it failed so it can fix the bug on the next try. Frameworks like reflection use verbal self-reflections to generate this kind of valuable feedback loop. The agent stores this critique to drastically improve its reasoning and decision-making on future attempts. It's literally learning on the fly.
If reflection is the brain's ability to self-correct, tools act as the agent's hands. By default, a language model is essentially trapped inside a box, right? It's limited entirely by the data it was originally trained on. But by equipping it with external tools, it suddenly breaks out of that box. It can browse the live web to pull real-time data, execute code securely, run statistical analysis on a massive spreadsheet, or even manipulate your local files through API interactions. The AI has the total autonomy to decide exactly when and how to pick up these tools to solve your problem.
Now, to make sure the agent doesn't just, lose the plot halfway through a complex task, it uses a highly structured memory system. The first layer here is short-term memory, which handles the immediate task context, like tracking the back and forth of your current conversation. The second layer is long-term memory. This is crucial because it allows the agent to store accumulated knowledge permanently, often by leveraging vector databases for incredibly fast recall. With long-term memory, an agent can remember your specific preferences or reuse a really successful strategy it figured out weeks ago.
Looking at the taxonomy of how these brains actually evolve, we can see a clear fast track from basic to advanced. At the bottom, you have simple reflex agents. These are completely reactive, kind of like a smart thermostat that just clicks on when the room gets cold. Moving up, model-based agents introduce an internal state to predict what might happen next. Then we hit goal-based and utility-based agents. These don't just react, they proactively search for the most efficient path to an objective. Add in a critic, and you get learning agents. And finally, at the very top, we have hierarchical agents, structured in tiers where managers delegate to subordinates. We can also categorize these autonomous systems by where they actually live and operate. Embodied agents interact physically with the real world or in simulated 3D environments. Think of advanced industrial robots adjusting on the fly on an assembly line, or dynamic NPCs in a video game reacting to what you do. On the flip side, we have software agents. These exist entirely within digital environments, automating your office workflows, managing sprawling email inboxes, you name it. For modern business automation, these software agents are where the most massive, immediate impact is currently happening.
Stepping back to look at the whole ecosystem, hierarchical software agents act very much like human corporate teams, and this structure creates phenomenal resource optimization. High-level agents set the overarching goals and the guardrails, while the lower-level specialist agents handle the gritty execution. It's just like a CEO. They don't micromanage the print or ink, right? They delegate. This drastically reduces duplicated efforts and ensures that expensive computational resources are only spent exactly where they're needed, preventing any single agent from just drowning in complex data.
But, and this is a big but, there is a catch. We have to keep this warning from the research in mind. While these hierarchical systems are highly efficient at delegation, they can become dangerously rigid. Fixed hierarchies really struggle to adapt to environments that change frequently. If the original architecture of the agent hierarchy is built too narrowly around a specific set of goals, a sudden, unexpected shift in the workflow could cause the entire system to bottleneck or honestly just break down entirely. Structure is vital, for sure, but flexibility is just as important.
So, to introduce that missing flexibility, we turn to multi-agent collaboration. Instead of a strict, top-down corporate hierarchy, imagine a highly collaborative war room of specialized LLMs working together. Different agents are assigned specific personas. Maybe one acts as a creative writer, another as a brutal fact-checker, and a third as a market analyst. They deliberate, debate, and critique each other's outputs to solve highly complex problems. And studies consistently show that this collaborative back and forth significantly improves logic, reasoning, and factual accuracy compared to just one single agent trying to do the whole shebang alone.
And this isn't just theory. AutoGen, which is an open-source framework built by Microsoft and academic researchers, turns this collaboration into reality. It allows developers to easily stand up systems using a core conversational agent to handle inputs and generate responses. You can inject a reflection agent into the mix to instantly self-assess the quality of those outputs, and, most impressively, you can spin up a group chat feature where multiple, specialized agents autonomously converse, share data, and even write and test code together without needing you to step in and referee every single interaction. In practice, tools like AutoGen Studio provide a really clean visual interface for this otherwise highly complex architecture. Instead of writing thousands of lines of integration code, you can visually configure your different personas right there on the screen. You can set up a user proxy to execute code, a travel planner, or a creative assistant. You are essentially assembling and tuning a custom, specialized digital workforce from scratch, mapping out exactly who talks to whom before letting them loose on your project.
Let's make this concrete and look at a practical example. Running social media marketing. In a multi-agent system, this becomes a completely autonomous, three-step workflow. First, the tweet writer agent drafts the initial copy based on your core topic. Second, it passes that draft to the content optimizer agent, who tightens the phrasing, injects relevant hashtags, and optimizes it for current algorithm engagement metrics. Finally, the final reviewer agent evaluates that optimized tweet against corporate safety guidelines and strict character limits. Once it passes, it gets approved for publishing. The team critiques, refines, and polishes the product entirely on its own.
As we wrap up this explainer, I want to leave you with a thought regarding this rapidly shifting landscape. We are actively transitioning from being operators who click the buttons to managers who define the goals and set the guardrails. If autonomous multi-agent ecosystems are going to handle the deep research, the code generation, the writing, and the optimization processes entirely on their own, well, your day-to-day role fundamentally changes. You are no longer managing the task, you are managing the intelligence. So think about it. When AI agents manage the workflow, what will you manage?